So hey there, welcome back to another video of Joffer Tech YouTube channel. In this and in the last video, we were talking about how to do a text summarization with Python, and here's the second step for this thing. So choosing a text source for abstractive text summarization, the quality, type, and density of information conveyed via text varies from source to source. Textbooks tends to be low in density but high in quality, while academic articles are high in both quality and density. On the other hand, news articles can vary significantly from source to source. Regardless of where the text comes from, the goal here is to minimize the time you spend reading. Thus, we will build a tool that can easily be adopted for any number of sources. For this example, we will use a news article on a recent global warming study from Science Daily as a text source. Feel free to use a different article. To extract the text from the URL, we'll use the newspaper 3K package. For From newspaper import article URL, you can give the URL and then article is equals to article, then URL article dot download and article dot parse. So now we'll download and parse this article to extract the relevant attributes. From here, we can view the article text at article.text. This is the text. We have this. So the next thing is clearly this quite a long and dense. This text will serve as an input for the summarization algorithm that will write in the next step. If your particular application requires extracting text from PDF documents, try out the PyPDF 2 package. Alternatively, if you have audio files that you need to be transcribed to text, try using the speech recognition package. Once you have the text in a format that Python can understand, you can move on to summarizing it. Step number three, summarizing text with Scapy. It's like Spacey. A human might approach the task of summarization document as follows: read the full text, understand the concepts and being conveyed, pick one of the most important concepts, simplify them in a more concise manner. For a computer to perform the same task, a semantic understanding of the text is necessary. It's like while semantic analysis is possible with the current NLP algorithms, it often requires significant computational power and produces results similar in quality to other extractive techniques. Rather than understanding the text, extractive summarization relies on quantitative metrics constructed from the text itself without attaching any exogenous meaning. Our approach is to simply look at the use frequency of specific words, some of the frequencies within each sentence, rank the sentences based on this sum. So, of course, our assumption is that a higher frequency word use implies a more significant meaning. This may seem oversimplistic, but this approach often produces surprisingly good results. To begin, we'll first need to import the different packages. Import Spacey from spacey.lang.en dot stop underscore words. Import stop underscore words. From string, import punctuation. From hand heap, you import n largest. We'll use Spacey to import a pre-trained NLP pipeline to help interpret the grammatical structure of the text. This will allow us to identify the most common words that are often useful to filter out stop underscore words, as well as add the punctuation. I punctuation will also use the n largest function to extract the percentage of the most important sentences. Our algorithm will use the following steps. Tokenize the text with Spacey pipeline. There's a segments. This segments will with the text into words, punctuation, and so on using grammatical rules specific to the English language. Count the number of times a word is used, not including stop words or punctuation. Then normalize the count. A word that's used more frequently has a higher normalized count. Calculate the sum of the normalized count for each sentence. Extract a percentage of the highest ranked sentences. These serve as a summary. We can write a function that performs these steps as follows. It's a function summarize text and it will take text and per as arguments. NLP is equals to spacey.load and we have in the parentheses we have en underscore core underscore web underscore sm. Doc is equals to NLP text. Token is equals to token to text for a token in documents. Word underscore frequencies and for you can read that particular code. Now that per is the percentage 0 to 1 of sentences you want to extract. To test it out to Science Daily article, run summarize article dot text slash 0.05. The output should look like this. You can read the complete article for yourself to judge how well this reflects the complete text. However, a summary is already provided by the author. At the top of the article, it reads global warming begets. Extreme warming, it's like paleoclimate study finds researchers observe a warming bias over the past 66 million years that may return on ISO. Pretty much spot on, right? Conclusion: use text summarization and improve your productivity with Python. So, maximizing your efficiency by minimizing the time you spend reading, you have dramatic impact on productivity. Whether you are reading textbooks, reports, or academic journals, the power of your natural language processing with Python and Space C can reduce the time you spend.